All right, let's dive into a really common but kind of tricky challenge, building a totally solid data pipeline. We're going to be moving data from SharePoint documents straight into a SQL database. And to connect all the dots, we'll be using the awesome workflow automation tool N8. Let's get our hands dirty. So this is the big question, right? You've got all this super valuable data, but it's locked up in CSVs, Excel files, you name it, just sitting there in a SharePoint library. How do you automate getting that data out, cleaning it up, and loading it into a database where you can actually use it for analysis and reporting? Well, that's exactly what we're about to build step by step. At its heart, this is a classic story of moving from chaos to order. Businesses literally run on documents, but for anyone working with data, that means critical information is basically trapped. Our mission here is to create an automated workflow that bridges that gap, turning that chaotic library of documents into a structured, queryable, and genuinely valuable asset in SQL.
Now, before we even think about moving a single byte of data, we have to build a secure foundation. Just like any good construction project, you gotta have the right keys to the right doors. So right here, we're gonna set up secure authentication to let our N8N workflow talk to the whole Microsoft ecosystem.
Inside Microsoft's Admin Center, this is our little three-step security dance. First, you register a new application. This basically gives your workflow an official ID card. That process spits out the three things you absolutely need: the client ID, the client secret, and the tenant ID. Think of them as the username, password, and address for your workflow. And finally, and this is so key, you have to explicitly tell Microsoft what that new application is allowed to do. Okay, listen up, because this right here is probably the #1 reason these connections fail. After you set the API permissions, you have to click that Grant Admin Consent button. Why? Well, it's essential for any server-to-server automation where there isn't a human sitting there to click an Allow pop-up. Skipping this step is the most common pitfall, so please don't forget it. So which permissions do you actually need? Well, if you're just reading files and their details, all sites.read is all you need. It follows that great principle of least privilege. But if your workflow needs to do something, like maybe move a file to an archive folder after it's been processed, then you're going to need the more powerful files.readwrite.all scope. Just pick the one that matches exactly what your pipeline needs to do. All right, security is locked in. Now it's time to build the pipeline itself. The best way to think about this is like an assembly line. We don't want to just dump a giant messy pile of documents into our machine all at once. Nope. We want to process them methodically, one by one. It's all about reliability and control. And this is the core principle. The secret sauce for a stable and resilient workflow is processing files sequentially, one at a time. This is what prevents memory from overloading when you're dealing with big files, and it avoids all sorts of weird compatibility issues with nodes that just aren't designed to handle huge batches of data. It might sound a little slower, but trust me, in the long run, it's way more reliable. So how do we make this one-at-a-time thing happen in our workflow? The answer is the loop over items node. This thing is the engine of our assembly line. It takes that full list of files from SharePoint and then feeds them into the next stage of the process, one after the other. It's perfect. And this number right here is the single most important setting for a stable pipeline. Inside that loop over items node, you have to set the batch size to 1. This one simple configuration forces the entire processing chain, downloading the file, extracting the data, cleaning it, everything, to finish for one file before the next one even starts. This is the absolute key. Batch size of 1 means stability. Okay, our assembly line is moving. We're grabbing files one by one. But now comes the really important part, the refinery. This is where we take the raw, often messy data that we've pulled from our files and we purify it. We make sure it's in the perfect format before it even gets close to our nice, clean SQL database. Think of this table as your data quality cheat sheet. Each row here tackles a super common problem that will absolutely crash a SQL insert. First up, the column names from your file might not match your database. The rename keys node fixes that in a snap. Dates are almost always in the wrong format. The date and time node standardizes them. Now, these next two are especially critical if you're working with MSQL. An empty string is not the same as a null value, and it will cause an error in a number or a date column. And a single quote in your text, that will break your entire SQL statement. For both of these, the code node is your best friend. It lets you programmatically clean the data before you try to insert it. This quote from the source material just sums it up perfectly. While all the dedicated nodes are great, the code node gives you the ultimate power and flexibility. It lets you handle all those tricky edge cases, like null values and special characters that could otherwise just stop your entire workflow dead in its tracks. It's your secret weapon for building a truly resilient pipeline. So our data is clean, it's standardized, it's ready to go. Now how do we get it into the database? We could take the slow, scenic route, but we're here for performance. It's time to upgrade our data delivery method from a bumpy country road to a superhighway. I mean, just look at the difference between slow and fast. The default way would be to insert each row from a file one by one. For a file with just 500 rows, that's 500 separate trips to the database and back. It's incredibly inefficient. The fast method, bulk insert, bundles all 500 of those rows into a single, powerful database call. The performance boost isn't just a little bit better, it's night and day. And achieving this superhighway performance is basically a two-step process. First, we turn back to our trusty code node. We use it to loop through all our clean data rows and build one single massive text string of SQL values clauses. Then we just feed that whole string into a SQL node that's set to execute query. It sends the entire dataset to the database in one efficient shot. Bam! We've built the pipeline. It's secure, it's robust, and man, is it fast. But our job isn't quite done. The final step is to build in the operational smarts that make sure this thing runs reliably for the long haul, even when stuff goes wrong. Let's be real, failures are gonna happen. A file might be corrupted, or maybe the database is down for a minute. The key is to plan for it. You'll notice that most workflow nodes have a dedicated error output, that little red dot. You should always connect this to a notification system, like Slack or email. That way, if a single file fails, you get an alert immediately with all the details, while the rest of the process just keeps on chugging. So, to wrap it all up, if you remember nothing else from this, remember these three architectural pillars. 1. Stability comes from processing files one at a time with a batch size of 1. 2. The code node is not optional, it's absolutely essential for that critical data cleaning that prevents errors. And 3. For any real-world dataset, you have to use the bulk insert pattern for performance. These principles are what separate a brittle hobbyist workflow from a true, enterprise-grade data pipeline. And with that, your pipeline is complete. Data is flowing freely and reliably from that document chaos into database order. So the final question isn't about the how anymore, it's about the what. What new reports are you going to build? What trends are you going to discover? What amazing insights will you unlock now that your data is friendly free?